So now we are going to work on subtracting integers. So first we're going to talk about how to model them using a number line. When subtracting a positive number, we move to the left on the number line. This is kind of like what you're already used to. So when you subtract a positive number, you move to the left. We're going to begin with the example 3 minus 8. 8 is a positive integer that we are subtracting from 3. If we begin with 3, we start with it on the number line, and then we move left 8 spaces. So I model that by taking 3 and moving to the left 1, 2, 3, 4, 5, 6, 7, 8 places. Where I end on the number line is my solution. So because I ended at -5, I can say that 3 minus 8 is -5. The same is true for an example where I take a negative integer and subtract a positive integer. I move to the left on the number line because I am subtracting a positive integer. So -4 minus 2, I start at -4 on my number line and I move to the left 2 places. 1, 2, and I end up at -6. So -4 minus 2 equals -6. Now, when subtracting a negative number, we move to the right on a number line. This is the opposite of how to subtract a positive number on the number line. So before we were subtracting a positive number and we moved to the left, now we're subtracting a negative number, so we're going to move to the right. So in our first example, we have 2 minus -3. Because we're subtracting a negative integer, we're going to move to the right on the number line. I begin at 2 on the number line, and I move to the right 3 spaces. So 2, 1, 2, 3. I end up at 5. So 2 minus -3 equals 5. The same is true if I begin with a negative integer and subtract a negative integer. Anytime I subtract a negative integer, no matter where I begin, if I'm looking at a number line, I am going to move to the right. So, beginning at -7, I move to the right 4 places. So that's 1, 2, 3, 4. I end up at -3, so -7 minus -4 equals -3. So, addition and subtraction are what we call inverse operations. This means that they undo each other. So now we can think of subtracting integers as adding the opposite. Have a look at this example. We already know that 10 minus 5 is 5. This is simply thinking about it in subtraction terms. But if we change our way of thinking a little bit and we say if we add the opposite, it looks something like this. 10 plus -5, because we know -5 is the opposite of 5. So now we're adding the opposite instead of saying 10 minus 5. Because we are familiar with our addition of integers rules, we now know that if we're adding 2 numbers where the signs are different, we find the difference and take the sign of the number with a larger absolute value. So here, what's the difference between 10 and 5? Well, that's 5. And the number with a larger absolute value is 10, so my answer is positive. So 10 plus -5 is 5, which is exactly the same as 10 minus 5 being 5. This takes us to our procedures that you're going to need to remember in order to solve your subtraction of integers problems on paper. The procedures go like this. When subtracting integers, you change subtraction to addition first, and then change the second number to its opposite. So we'll be adding the opposite. And then the third step is simply to follow your rules for integer addition. So in our first example, you're asked to subtract 5 minus 9. We're going to just take this step by step to show you what it looks like. 5 minus 9, if I follow the first step to change subtraction to addition, I just change subtraction to addition. And in the second step, I change the sign of the second number to its opposite. So 9 becomes -9. So basically in one step, and these steps can combine to being one step once you're comfortable. 5 minus 9 becomes 5 plus -9. So once we get to this step, now it's just an addition problem, and we know our integer addition rules, so we say, well, what's the difference? Because the signs are different. The difference between 9 and 5 is 4, and I take the sign of the larger number in absolute value, which is negative, so my answer is -4. So I can go back and say, well then, I know that 5 minus 9 is -4. If you weren't sure and you still wanted to model it on a number line, you can consider 5 minus 9 and look at the number line and say, well, if I'm subtracting a positive number, I move to the left on the number line. So 5 minus 9, I move to the left 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what do you know? You end up at -4. Now we're just going to work through our procedures and practice some subtraction of integers problems on our own. So I have -9 minus -2. I'm going to say, well, I'm going to change subtraction to addition and change my second number to its opposite. Now I'm adding numbers that signs are different. Signs are different, find the difference. The difference between 9 and 2 is 7. And the number that's larger in absolute value is 9. It's negative, so my answer is -7. Example C, -4 minus 3. Well, I'm going to change subtraction to addition first. -4 plus, and 3 is positive, so I'm going to make it -3. Now, this is an addition problem where signs are the same. When signs are the same, add and keep the sign. -4 plus -3, well, 4 plus 3 is 7, so my answer is -7. In example D, I have -3 minus 1, so I'm going to just follow my procedures, change subtraction to addition, and change the second number to its opposite. That will look like -3 plus -1. Again, signs are the same, add and keep the sign. 3 plus 1 is 4, so -3 plus -1 is -4. And lastly, I have -2 minus -4. I will say, well, -2 plus the opposite of -4 is 4. Now I'm adding. Signs are different, so I find the difference. The difference between 4 and 2 is 2. And I take the sign of the number with the largest absolute value. That number is 4. 4 is positive, so my answer remains positive.